Thank you guys for waiting so patiently, and thank you for joining. I'm gonna try to do this very quickly. This didn't go as planned, so I have a few demos to show you, and unfortunately, this is what we could have, a PDF, and not the presentation, but we'll go through it. So yeah, thank you. My name is Nicolas Vazquez, and I work for ShapeBlue as a software engineer. And this talk is about VM console enhancements that are planned for the next CloudStack release for 18. We are planning a bunch of enhancements for the VM console functionality. So the VM console is something that is very basic. It's just displaying the VM console. So it's nothing new, but there are enhancements to that. On top of that, like we have a new API for the accessing the console. It's not only embedded into an iframe, an HTML iframe as it was before. We have security tokens, security enhancements, connection securities enhancements that we are going to see. So this is the agenda. I will start with a bit of a history of how it evolved in the past from the Ajax-based BNC client into the modern BNC console proxy. We have the new API and extra validation. And then for the last one, this is an in-progress feature that we are also targeting for CloudStack 4.18, and is about connection security from the CPVM to the host. So a little bit about me. Yes, I told you I'm a software engineer at ShapeBlue. I'm a committer and a PMC member, also father of a 3-year-old young lady, and yeah, I love some sports as well. So BNC is the protocol that we follow for displaying the console, client console. I had some animations there, not gonna show on the PDF. The BNC, to being able to display that console, it is a server client model. So we connect to a server and we display the console. That's very easy. The keyboard and mouse events are transmitted. So that's how it works. And basically the protocol that is in charge of doing that is called RFB protocol, which we'll see a bit further in this talk. Good. So how do we connect to a VM console in CloudStack? We have a special VM, which is called console proxy VM. Inside the console proxy VM, we have like two sides. From the user side, it is an HTTP server listening for incoming connections, that it gets requests, and then it connects to the other side. It's connected to the hosts where the VMs are running, and that is where the VNC connection is open. It is a TCP connection that talks RFB, that protocol that handles the BNC display. And we have the proxy in the middle that proxies the traffic and allows the users to display the console and interact with that. And that is all handled by the console proxy VM, which is a special VM we have in CloudStack. A bit of evolution we had. This was the old console in CloudStack. If you remember and have used it for some time, you had some controls at the top, and it was not very fast. We'll go through that later to see why it wasn't that fast. And on the right side, we have the new one, which is using NoVNC. That NoVNC is a JavaScript client that handles things more properly. So we'll see why. The legacy one, the one we had at the left, it was an Ajax-based console. That means that this Ajax BNC client was listening continuously for HTTP requests. So every 2 or 3 seconds, it was polling the service to get requests. So that increased the network traffic a lot. So we had per VM, in which I had a demo that I'm not going to be able to show you now. But I did, like, I was displaying the console and showing you the traffic that it was involved when using the old Yeah, it's not here. Let's see. This was the video. No, not possible. Okay. So this was polling every 2 or 3 seconds for requests, and that was kind of not efficient in terms of network traffic. That's why we have introduced the NoVNC client inside the console proxy. The NoVNC client talks to a WebSocket server. So in the console proxy VM, we have added a WebSocket server. And the difference between polling and the WebSocket is that we only have one connection. And from that connection, the client and server interchange messages. And there's no need to do more requests. So you only do one connection, and over that connection, there's all the traffic going. So we proxy from there, from the server, and to the client. It started as a SHISOC project in 2017, and was first introduced into CloudStack in 4.15. Here was the video. I'm gonna try to play it again. No, just an image. Okay, so just to imagine what I was going to show you, there is the view console button. So I was showing to press there, and you were seeing the old console. And on the right side, I was showing the browser console to get the traffic, and we were going to see the requests every 2 or 3 seconds. And on the other side, the same thing, the same CloudStack operation to display the console, but with the new client. And yeah, it's not possible. Sorry for that. And okay, a bit more about the VM console. So CloudStack has a group of system VMs, which are these console proxy VMs, that handle the connection to VM's console. So we have these special VMs talking to the management server, and the management server interacts with those to give the access to the user. And the user then connects directly and can see the console. So this is the process. When the user is authenticated, it requests to display a VM console. Then the management server goes to one of these CPVMs. It gives you a token, a URL. It was first embedded into a web page, which was we had to get the URL from inside that HTML page and then paste it if we wanted to use it directly. So that was a limitation because it was kind of tied to the CloudStack UI. It didn't allow other clients to use it. So here it's the explanation of that. So you see the first request from the user. It was a request to the special URL, which says command equals access. That and also you provide the VM ID to the management server, and the management server gave you the HTML page with a URL embedded within that page that points to the CPVM. Then in the browser, you use that page to do a connection to the CPVM. The CPVM has that server inside that listens for requests and then connects to the hypervisor. So that's the full cycle to get the VM console, right? And that's how it was working, how it's currently working in 4.17. But in the next 4.18, we have added the possibility to interact with another layer, which would be any external service like internal cloud or whatever that interacts with CloudStack. And that is done via a new API, which is this create console endpoint. And now the difference is that you are not tied to the CloudStack UI or to the URL to simply request that. You can do it via API. It's more programmatically better. You use an API, you receive the response, and in the response, you get the same flow. Connect, and then the CPVM does the connection to the hypervisor. And that results on the CPVM. Good. So what is this new API that allows to interact with another service layer? This new API will accept the virtual machine ID, and it will return a URL which you can use to connect directly to display the console. That allows you to use different UIs. There's no need to use the CloudStack UI. You can use another UI. You can bypass the UI and directly connect to the WebSocket. That I show you that the CPVM has a WebSocket server. You can directly connect to that WebSocket server without the need to use the CloudStack UI. So we have this information, the host, the port, path, and the token that it gives. So you can also connect. And there is an optional parameter, which is an extra security token that you can pass to the API. This security token is to add another layer of security in case you want to protect the connection. So we'll see. This is an example of a response. You see the URL is provided here, the WebSocket information, and also a token. Good. With that information, the CloudStack UI is now enhanced to get that URL and works directly, so there's nothing to be done for the next. In the 4.18 CloudStack UI, that is done out of the box, so you don't need to change anything. You just simply click the View Console button and it will work. But you have now a new API which you can integrate with other systems. That's the enhancement, basically. And there's also internally, that URL can be used only once per session. So let's say an attacker gets your URL and tries to connect, and it's not authenticated in the CloudStack on the CloudStack system. So it will paste the URL, and with the previous behavior, it could connect to the VM, and that is enhanced as well. So it's only used one time. I had the demo for that, so I had generated a URL console. It gave me a URL. I pasted it on the browser one time. It connected for my user. Then I tried to paste it on another tab on another browser, and it didn't let me connect because that session was already used. And that is to avoid those replication attacks. Okay, sorry, no demo time. So that was basically what I was going to explain. And there was also the security token validation, which is this extra parameter, the second one, token. When you pass that token to the API, then you let the CPVM know that it should expect a new parameter. So when CloudStack generates the URL, it gives an extra parameter that it needs to be set in order to connect. So let me see here. You see, if I pass token, the extra parameter will be needed for the WebSocket connection to be passed. If that doesn't match when you try to connect to the CPVM, then the CPVM connection to the host fails. It only succeeds when they match. And yes, that was the demo, which is here, not working. Okay, sorry. Okay, secure. Okay, there is also another enhancement that allows you to switch the WebSocket port running in the CPVM from the secure port, which is 8443, to the unsecure port, which is actually the default port. So by default, your WebSocket server listens on 8080, and that remains being the default. But there's now the possibility to switch it to 8443. And this is, one second, let me go up for a second. In this diagram, the first connection, which is to the WebSocket server, which should be this connection, could be secured if you are using 8443. And that can be easily done by switching some configuration in CloudStack. And then the next feature we're going to see is to encrypt that connection between the CPVM and the hypervisor. So we'll see that doing this, setting this configuration in CloudStack to true and providing a valid certificate for your system VMs, then you can simply regenerate the CPVM, and when it is running again, it will be listening on port 8443. We'll have the WebSocket server running on that port, and the IP table rule to allow in the traffic on that port as well. So, and in case you do not meet any of this, then it will be simply generated with port 8080. And that's to secure the connection between the user or the client to the CPVM. There's a screenshot here that you'll see in the URL. The port is there switched to 8443, but internally it's the same port that is used for listening on that server. Good. And now the final enhancement, which is the connection between the CPVM and the host. So by default, this is unencrypted as well. The only security that we have currently is the password protection, like BNC authentication, when doing that connection. And we are working on a solution for KVM that uses the CA framework. The CA framework provides X509 certificates to client and server. So we already, by this framework, the CPVM and the KVM host already have those certificates. So we can use them to protect the connection between those. So when a CPVM requests connection to a host to get the VM, the client in that connection, which will be the CPVM, needs to present the certificates to the host, right? And to let the host know that it should use those certificates to compare them and to allow the connection, we need to enable TLS on the host side, on libvirt. And yeah, there's a guide, very easy steps to follow to enable that. You need to enable a setting on the qemu.conf file, and then when you have your certificates, then you simply let QEMU to know where are they located. So there's nothing difficult on there. Then you restart the service, and your QEMU is listening. It's accepting. It's being secured, right? But what I learned from experience is that it's not that simple. So I'm going to share you some findings that I had while trying to develop that. So I have found out, going deep into this RFB protocol, that we are using a version for 3.3 that does not provide the TLS security. So even though I enabled it on the KVM host, then the client will not use a version that supports it. So the only security that it provided are 3 types: 0, no security. No, actually 0 is like connection has failed, so there's only 2. No security, and BNC authentication, which is password authentication, the one we use already. So if you have already checked the CloudStack database for each VM, depending on the hypervisor, we have a password field, which depends on the length by the hypervisor, I think. But that is used to authenticate to the BNC server, right? To get the console. And as those are the only 2 types of security that the version 3.3 provides. So yeah, I needed to upgrade that to version that supports it. And I discovered that by reading the RFB protocol, RFC, that version 3.8, 3.7 and onwards support it. So these are the main differences. When starting a BNC connection, an RFB connection, the server tells you the maximum version it supports. So there was a problem there because if you don't encrypt, if you don't enable TLS on QEMU, then this should be 3.3, which is not good. But if you enable TLS on libvirt, then comes to be 3.8, like in that case. But now the problem comes from the client, which is the CPVM. The CPVM replies with the major version that it supports. So if we have, in our case, we were having a CPVM that supported version 3.3, and that didn't provide any security type that we need. That was insufficient. So needed to enhance all the protocol to work with version 3.8, which I'm not going into detail because it was a bit of a mess, and doesn't provide any new thing. You just see the console. But the difference is that then the server, during the handshake, sends the number of security types it provides and give you a list. And on that list, from that list, the client chooses the one it's using. And yeah, from that list, there is one special security type, which is called bencrypt. And the bencrypt contains a lot of security types, which the one that matches the QEMU TLS is the X509 certificate plus BNC authentication. That's the one we will use. So using that security type, the client sends its certificates to the server compares. Once it sees that the certificate is issued by CloudStack, then it allows the VM console access. For now, it is only supported by KVM, and it's an in-progress feature, so also been targeted for 4.18, but not really done yet. So in summary, on the next 4.18, we will have the new API, the security validation via the API, and the WebSocket port encryption. And also being targeted for 4.18, but not sure yet, this enhancement on the security connection from CPVM and the host. And yeah, that's it. If you have any questions, yeah.
Thank you, Nicolas. Well done. Difficult talk there, but you got through it. Well done. Question, Shiv?
Will the old method work?
Which old?
The HTTP one.
Yeah, it worked, yeah. You mean with the console, the security, or what?
Yes, so in 4.18, once that is released, is
Yes.
it going to be only via API, or will the old method also work?
No, it will be via API.
Only?
Yes.
Okay.
Yeah, the new API will be the default
Method of...
default method, yeah.
So the old sending the password and getting the console link is not going to work in 4.18?
Not via the URL, no. You need to use the API, and the API will give you the same.
Okay.
It's just a replacement. Instead of doing it via browser, you do it via API.
Got it. And I assume that since it's an API, it will be a client access key and secret key, and not the password.
Yeah, the same as any other API.
Any
yeah.
other API.
Yeah.
Okay. Thank you.
Thanks.
You said the new TLS encryption is supported by KVM hypervisors.
Yeah.
But let's put you have a mixed environment with KVM and VMware hypervisors. If I configure TLS encryption to be on, would it fall back when it try to connect to a VMware console?
So I think when you have a mixed environment, you have two CPVMs, right? One for KVM, another for VMware. And I'm not sure in that case if that is smart enough to know which one is running on which to pick the correct CPVM. I think it will. So they are? Oh. Okay. So yeah, I think they could handle that as long as you configure the KVM.
Okay, thank you.
Yeah.
Any more questions from the room? Okay. Please give Nicolas a big round of applause. Thank you, Nicolas.
Thank you.